here we have a rational equation to solve. It's x minus 2 over 3x minus 9 plus 3 over x squared minus 6x plus 9 equals x over 2x minus 6. The first thing we've got to take care of is factoring all of the denominators. So we have x minus 2 over, I'm noticing a common factor of 3 that we can factor out in the first denominator. So in factored form, it would be 3 times x minus 3. For the second denominator, we've got 3 over, it's a trinomial, so we'll need to create 2 sets of parentheses to prepare to factor it. X times x would make x squared. Now I'm thinking what times what is 9, that adds up to negative 6, and that would be a negative 3 and a negative 3. So it factors as x minus 3 squared, effectively. And then on the right side, I'm noticing there's a common factor of 2 that we can factor out from both terms in the denominator. So it'll be 2 times x minus 3. Okay, all denominators are now factored completely. The next thing to do is to write down any restrictions on the variable. So it's helpful to make a note to yourself at the top of what x is not allowed to equal. Here, x cannot equal any value that makes any of the denominators 0. So 3, because 3 subtract 3 would make this factor 0, and it would 0 out the denominator there. So x can't equal 3. And is there any other x value that x can't equal? 3 as well from right here, 3 from right there, and also 3 from right there. This is the only restricted value. X can't equal 3. So if we solve the equation and happen to get 3, we'll know that that's not a solution. It doesn't check. Next thing to do is to multiply both sides of the equation by the least common denominator. So I'm going to write down what I think the least common denominator is. We have a 3 and a 2. The least common denominator always is the least common multiple of all of your denominators. So the least common multiple of a 3 and a 2 is 6. We need a 6 in the LCD. How many factors of x minus 3 do we need? We've got a single factor of x minus 3 in the first denominator. We've got x minus 3 squared. We've got it twice in the second denominator, and we've got it once in the third denominator. You always go with the highest exponent that occurs on the factor. Here we have x minus 3 squared, so we need x minus 3 squared in the LCD. So we've got to multiply both sides of the equation by that, by 6 times x minus 3 squared. So I'm going to show that I'm multiplying the left side of the equation by 6 times x minus 3 squared. I put brackets around it. You can put parentheses if you prefer. And on the right side, we also need to multiply by 6 times x minus 3 squared. Okay. So on the left side, we need to distribute the 6 times x minus 3 squared to both terms. And if you can do this mentally, then that's fantastic. I'm going to show this step. So 6 times x minus 3 squared times x minus 2 all over x minus 3, and then plus the 6 times x minus 3 squared times the second fraction on the left, 3 over x minus 3 times x minus 3, which can just be written more simply as x minus 3 squared. And then on the right side, there's no distributing that needs to take place. There's just a single term on the right, so we can start reducing. 6 divided by 2 is 3, so we can reduce there a little bit. And also one of these factors of x minus 3 can be canceled. I just crossed off the x minus 3 from the denominator, and then I crossed off the squared from the x minus 3 that we're multiplying by. There's just a single x minus 3 left after simplifying. On the right side then we've got a 3, an x also, and an x minus 3. So the right side is a little simpler. The fraction's been cleared. On the left side, we need to do similar simplifying here. So 6 divided by 3 is 2. 3 divides into 6 twice. And then we can cancel one of the factors of x minus 3, the x minus 3 factor from the denominator, with one of them that we're multiplying by. So I just crossed off the squared. That leaves us with 2 times x minus 3 times x minus 2 for the first term. The fraction's been cleared. And then plus, for the second term now, we've got a 6 times 3, which is 18. And then the x minus 3 squared completely cancels itself out there, and the second term just simplifies to the whole number 18. On the right side, then, we've got to distribute the 3x through the parentheses. That makes 3x squared minus 9x. Okay, so notice at this stage, we've completely cleared all of the fractions from the equation, which is great. That means we're on the right track. Let's size up what we need to do now. On the left side, we've got a FOIL. We've got to multiply the x minus 3 by the x minus 2, and then eventually distribute the 2 through. So I'm going to multiply x minus 3 times x minus 2 now by the FOIL technique. That's going to be x squared minus 2x minus 3x, and then plus 6. And then bring down the plus 18. On the right side, there's no further simplifying that can be done at the moment, so just copy down 3x squared minus 9x. On the left side, we've got like terms here within the parentheses. That's negative 5x altogether if we combine the negative 2x and the negative 3x. So x squared minus 5x plus 6. We'll eventually then need to distribute the 2 through to clear the parentheses on the next step. Plus 18 equals 3x squared minus 9x. Let's distribute the 2 now to clear the parentheses. That's going to be 2x squared minus 10x, and then plus 12 plus 18 is equal to 3x squared minus 9x. So this is a quadratic equation. We have x squared terms present, which means we're going to need to get all terms on the same side with 0 on the other side, and then solve it by factoring by the zero product rule. To get there, let's combine like terms. We've got a 12 and an 18. First of all, that's 30. So on the left side, we have 2x squared minus 10x plus 30. On the right side, we've got 3x squared minus 9x. I want to bring all terms to the right side because there's more x squared terms on the right than there currently are on the left, and we want to have the x squared coefficient to be positive. So I'm going to bring all 3 terms from the left side over to the right. If you can do this mentally, that's fine. I'm trying to show what I'm up to. So I'm subtracting 2x squared from both sides, and I'm also going to add 10x to both sides, and then subtract 30 from both sides. Okay. So just trying to indicate how I'm getting everything to the right side there. So therefore, we got 0 on the left. Every term has been moved over to the right. And then we got 3x squared minus 2x squared, which is just 1x squared on the right side. Negative 9x plus 10x is plus x, and then a minus 30, or a negative 30. Okay. So the equation is now set equal to 0. It's a quadratic, which means we've got to try to factor the trinomial here, and then set each factor equal to 0. This is solving by the zero product rule. So x times x would make x squared. Now I'm thinking what times what multiplies to give me a negative 30, and then they need to add up to a 1. So that could be 6 and 5. If we make it a positive 6 and a negative 5, we'd have a negative 5x and a positive 6x, which adds up to positive x, and then a positive 6 times a negative 5 is negative 30. So once you have a quadratic equation set equal to 0 and factored, the next thing to do is to set each factor equal to 0. So I'm going to set x plus 6 equal to 0, and then or x minus 5 could also equal 0 here to make that equation true. We've got 2 solutions out of this. Subtract 6 from both sides, and one of our possible solutions is x equals negative 6. And then or the other possible solution, if we add 5 to both sides of this other equation, is x equals 5. We've got 2 potential solutions. We've got to check them to make sure they work in the original equation by making sure that they're permitted and by comparing them to the restricted value initially. X could not equal 3. We did not get 3. That means both of these answers are valid, and we can just stop at this point and conclude that we have 2 true solutions to this equation. If you like to write your answers in solution set notation, you could write the answer like this. Inside set braces negative 6, comma, 5. So we have 2 solutions that both check.